welcome to this section. Now we will cover methods. Methods are fundamental building blocks of the classes that we write in object-oriented programming. Do you remember that a few sections ago we mentioned that a class defines the state and the behavior of an object? Well, in this section, by covering methods, you will be learning how to define the behavior of the object, because so far we have been focusing on the state, the attributes of an object. We can define a method as a function that is associated to an object of the class or to the class itself. The methods defined in a class will determine the behavior of the objects that are created from the class and how they can interact with their state and with other objects. So we're basically defining all the actions that the object can take. There are three main types of methods: instance methods, class methods, and static methods. In this section, you will learn how to work with instance methods. Instance methods, in particular, are methods that belong to a specific object because they have access. They have access to the state of the object that is calling them. And how do these methods get access to the internal state of the object? Well, through itself. Through this parameter that we have been writing so far as the first parameter in every single method that we've defined in our class, like init, like getters, and setters. Remember that in a previous section we said that self refers to the object or the instance. Well, in the case of a method, it refers to the instance that is calling the method, that is asking to execute its functionality. Calling a method is very similar to calling a function, because we are asking the program to run its functionality or to execute its lines of code. But this time, it is a specific object that will be calling the method. Let's see what we can learn about methods in the documentation. Right here, we can go to the official documentation where it says classes. We go to the article that covers classes, and we click right here in section 9.3.3, Instance Objects. We click on it, and right here we can see a short description of the instance objects that an object can contain. In this paragraph, we see a short description of what a method is. So let's read it. The other kind of instance attribute reference is a method. A method is a function that belongs to an object, just like you learned in the definition right now. In Python, the term method is not unique to class instances. Other object types can have methods as well. For example, list objects have methods called append, insert, remove, sort, and so on. And I'm sure that you've used these methods before. However, in the following discussion, we will use the term method exclusively to mean methods of class instance objects, unless explicitly stated otherwise. So the key takeaway from this article is that a method is a function that belongs to an object. You will learn how to define these functions, how to call them, and how to work with them in your code. In a general overview of the class structure, this is a typical class in Python, methods are defined below the init method, after the init method in the class. So right here we would have our first method and then as many methods as needed for the class. And they also have to be indented to the same level as the init method and the class attributes so they can belong to the class. If a method is not indented, then it's not considered part of the class anymore and it is considered a regular function from the main program. This is the basic syntax that we need to use to define a method. First, we have the def keyword, followed by the name of the method. And right here we have the list of parameters, including self, and as many parameters as needed. Just like when we define a function, we can define as many parameters as we need. Of course, they have to be separated by a comma, and it is recommended to add a space after the comma. This is recommended in the Python style guide. You shouldn't need to add many parameters to this list of parameters, and if you do need to, there is usually a way to redesign your code to reduce the number of parameters in this list. Method names usually include verbs, since they represent the actions of an object. When we identified classes in a problem statement, remember that we identified the nouns. Well, now methods will be identified through the verbs, because they represent the actions that an object can take. For example, a calculator class may have these methods: add, subtract, multiply, divide, and other operations. A deck class, like in a deck of cards for blackjack or for war, will have methods like these ones: build the deck, show the deck, shuffle the deck, draw a card, and other operations that are important for that particular object. Let's see the naming conventions for these methods. How should we write their names? Let's see this in the Python style guide. Let's see what it recommends. If we go to PEP 8, the style guide for Python code, we can learn more about how we should name methods in a class. We just need to go right here to naming conventions and method names and instance variables. Let's see what it says. Use the function naming rules for methods and instance variables. Write them in lowercase with words separated by underscores as necessary to improve readability. And we should use one leading underscore only for non-public methods and instance variables. So you can see that this naming convention of adding one leading underscore for non-public members still applies for methods as well, not just for attributes. So if you want to make a method non-public, you should add one leading underscore to its name. So, based on what you just read, this is the typical format for a method name. We write it in all lowercase letters with the words separated by an underscore. This naming convention is called a snake case. And it is the same naming convention that we use for function names and for variable names. Now let's see an example of how you can define a method in Python. We will define a method in our circle class. First, we write the class header and then we write the init method. In this case, so we can focus on the methods, we're just going to add one instance attribute, the attribute that we need to implement our method, which is the radius. Our method is going to find the diameter of the circle, which is twice the value of the radius. We're going to take this attribute and we're going to use it to find another value. It will be a function associated to a circle object. And how can we do this? First, we use the def keyword, just like we did when we defined getters and setters and when we defined init. Now we write the name of the method. In this case, we call it find diameter. We could also name this calculate diameter or get diameter or print diameter, anything that describes the functionality and the effect of our method. Of course, for instance methods, we always have to add self as the first parameter. And then right here, with one level of indentation to the right, we write the actual code that we want to run when this method is called. So let's say that we want, in this case, to print the value. And we say diameter. We have an f string, so we can write this right here, self.radius times 2. And what will this do? Well, this will print this message. This message is an f string, so this will be replaced by the actual numerical value. The radius will be replaced right here, it will be multiplied by 2, and then that value will appear right here after the word diameter. This line of code will run whenever we call this method with a circle instance. Another alternative could be returning a value. You can return a value from a method just like you return a value from a function. Using the return statement, and you just write the value that you want to return. In this case, it would be the radius of the instance multiplied by 2. Awesome, so let's go back to our initial version where we print this value. And this is how you can define a method in a Python class. Awesome, you know the basic syntax now. If you need to add a parameter for this method, you would just add it like we added the second parameter in the setter. We would do something like this. We write a comma, a space after the comma, and then the name of the parameter. And as many as we need to. Welcome to this coding session and this practical example. In this case, we're going to work with our backpack class, but now we're going to add some functionality to our class. So we will be able to add items, remove items, and check if an item is in the backpack. Well, so let's get started. First of all, we have to define init to assign an initially empty list of items to the backpack. We will also provide a getter like we have right here, like you learned in the section where we covered properties. So we want to create a read-only attribute, a read-only property with only a getter. We want to be able to add an item to the backpack. So for that, we just need to write or create or define a method called addItem in our class. It has to take self as the first parameter, and then the second parameter can be, for example, item, the item that we want to add. What do we want to do with that item? Well, first of all, we want to check if the item is a string. So we can check this with the isInstance function. We say item and then string. If the item is a string, then what do we want to do? Well, we want to append or add that item to the list of items in the backpack, this one right here. When we create the backpack, that list is initially empty, but if we want to add an item, we will have to append it to this list. Okay? So that is the power of self right here, that we are taking it as a parameter. Just like we use self right here to create an attribute, we use self as well to work with those attributes in our methods. If this is not the case and the item is not a string, then we could, for example, write this message. Please provide a valid item, or please enter a valid item. Great, we have our addItem method. Now take a moment to think about how you would implement the removeItem method. You know the basic syntax? This line right here, you just have to adapt the name to remove item and then try to implement the body of the method. What do we have to do to remove an item from the backpack? Think about this for a moment, pause the video, and then come back. Welcome back. So to define this method, we have to write the def keyword and then the name of the method, removeItem. We also have to add a second parameter because we want to be able to specify what item we have to remove. If the item is in the backpack, so if it is in the list of items of the backpack instance, then we have to remove it from that list. We take the list and then we call remove. And what are we going to remove? That item that we received from the method call. Now, what happens if the item is not in the backpack? Well, we have nothing to remove. We can, and it is very common, to return a particular value that indicates the user or the object that called the method whether the operation was successful or not. For example, if the item was in the backpack and it was successfully removed, then we can return the value 1, for example. And if this is not the case, if the item was not in the backpack, then we could return 0. And this is an example of a method that actually returns a value. You will see how this works when we start calling methods, and you will see how you can store this value and use it in your program. Great, so we have our 2 method definitions. We only have to implement our third method right here. In this case, this will be a short method, hasItem. It will return true if the backpack has the item and false otherwise. What do we want to return in this case? We want to return true if the item is in the list of items, like this. This expression will be true if the item is in this list, and it will be false if the item is not in the list. So we can just return this value directly. And we have a method with just 1 line. That is really awesome, right? We added functionality to our backpack. And we will use that functionality when we reach the part of the section where we start calling methods and using them in our program. Once we have our method defined in our class, we will need to actually call the method to tell the program that we want to execute it or run its functionality and its lines of code. Previously we said that calling a method was very similar to calling a function, but there is a small change in the syntax because instance methods now belong to the actual objects that we create from the class. So since they belong to the objects, we need to specify the object before the dot. Right here, we are using dot notation. As you can see right here, we have the dot. After the object, we write the dot and the name of the method. Then after the name of the method, we write within parentheses the list of arguments or values separated by a comma and by a space after the comma. Let's see these examples. I'm sure that now with these examples, you will realize that you've actually been working with object-oriented programming since you started learning how to code in Python. Let's say that I defined right here a list, 4, 5, 6, 7, and 8. This is an instance of the list data type, of the list class, and basically everything is an object in Python, so this is an object as well. I'm sure that you must have written this like 1,000 times. This is just a line where we add an element, the element 14, to the end of this list. Well, let me tell you something. This is an example of calling a method. Yes, that's right. We are writing a list object right here, the variable that references that object in memory, followed by a dot, then the name of the method, which is append, and then we pass one argument, which is required by the method, 14. Because we need to specify what element we want to add. Similarly, there are other methods that do not require any arguments, like for example, sort. If we call the sort method on the list object, we just need to write empty parentheses because we don't have to pass any arguments. This method will just sort the list in ascending order. In this case, it's already sorted, but it would sort it in ascending order. Then append takes one argument, and there are other methods that require other data types as arguments. For example, the extend method to add those elements to the original list, to this list object that we have right here. So as you can see, methods are very versatile. They can take as many arguments as we need, and these arguments can be of any data type that we need. Let's add some print statements to see the effect of these methods on the list object. Right here, we can see the 3 different stages of the evolution of the list in the program. We have the original list, and after that we sort it, which in this case leaves the list intact. Then we append the value 14, and then we extend the list with the values 1, 2, and 3. When we return a value from a method, we can assign it to a variable. In this case, we are calling the pop method of the list object. This method doesn't take any arguments, and it returns the last value in the list. Since the value is returned from the method, it is not printed, it is returned, we can assign it to a variable. In this case, we are naming this variable number, so we can print that value. Now if we run the code, we see this value right here, the value 3. The last value in the list was returned by the method, and it was at the same time removed from the list. If we print the list right here, we can see that it doesn't have that element after it is popped. This is an example with a list, but I'm sure that you've also worked with string methods and dictionary methods and tuple methods and all types of methods for the built-in data types. In this section, we will focus on writing methods for our custom classes that we define in our code. For example, right here, if we are working with a class that we defined, a circle class, and we have a circle instance, let's say that we want to call the find diameter method, then we would just write the name of the variable that holds or references the circle instance, followed by a dot, and then the name of the method. After the name of the method, we would write empty parentheses, because in this case, no arguments are needed. Let's try this in our code with a circle class. Right here, we have our circle class with the init method, and we have the find diameter method. Now you're going to learn how to call methods from classes that you have defined. Let's create an instance, myCircle, like this, and its initial radius will be 5. How can we call a method from the class? How can we, for example, find the diameter of a circle? The basic syntax is this one right here. We write the name of the variable, followed by a dot, and then we call the method like this. We write the name of the method and parentheses. If the method takes any arguments, then we pass those arguments. But if it only takes self, then we don't have to pass any arguments. Self is like skipped from the list of arguments, just like we skip self from the list of arguments when we create the instance right here. The same happens with the method, because actually behind the scenes, this instance is assigned as the value of self, a reference to this instance in memory. So we don't have to specify it ourselves within parentheses. Great, so now we see in the method definition that the value is returned by the method. So for us to use it, we will need to assign it to a variable. We say, for example, diameter. And if we print that variable, we will have access to the value. And we can use it anywhere in our program. Let's save the file and run the code. We see this right here, the value 10. The radius was 5 and the diameter is twice the radius. So the value is correct. We call the method right here from myCircle instance. The value of the radius of this instance was used for the calculations, and we got the value that was returned by the method, so we could use it in our program. And this is how you can call methods defined in your classes. Welcome to this example. Now you will practice how you can call a method of a class by working with the backpack class. Remember that in a previous video we defined these three methods: add item, remove item, and has item. So we will see how they work and how you can call them and use them in your program. First of all, we have to define a backpack instance, like this. After we have our instance, we are going to print the initial state of the items attribute or property. We want to confirm that the items list is initially empty, like we have right here. So we've confirmed it. So far, so good. Now, what do we want to do? Let's say that we are preparing for a camping trip. The first thing that we want to add to the backpack is a water bottle. We take the backpack instance, and then we have to add an item to the backpack. We use dot notation for this purpose. We write the name of the variable that references the object, then we write a dot and the method, the name of the method, and any arguments that it requires, of course. This one requires the item that we want to add to the backpack, right here. So after we add the item, we want to print the state of the list again. We want to see how many items are in our backpack. We see that before it was empty, and now we have one item, which is a water bottle. After that, let's say that we want to add another item. Try to do this yourself. Add the item a sleeping bag to the backpack. Pause the video, write this line in your code, and then come back. Remember, a sleeping bag. Welcome back. So let's add this item. And after that, we are going to print the state of the list again. We want to see how it is working. Well, we have an empty list, and then we have a water bottle and a sleeping bag. So our backpack is actually looking like a backpack for someone that is going camping. And that is really cool. Let's say that a friend is asking us if we have the water bottle in our backpack. How can we check this? Well, by calling the method hasItem that we defined right here. With this method, we can check if a particular item is in the backpack or not. So let's do that. My backpack.hasItem and water bottle. Let's save the file and run the code, and you will see something very peculiar right here, very interesting. We see the list of items in 3 different states, but right here we don't see any output coming from this line. We don't see true or false, and why is that? Well, because if we go to the method definition, we actually have a return statement right here. We are not printing true or false. We are returning the value. So, since we are returning the value, we have to assign the value to a variable to be able to work with it in our program, or use it directly. But in this case, we're going to assign it to a variable. The variable will be hasWater. Okay, this will be true or false. And now we do see the value true right here. We see the three states of the backpack, and then right here we see true, printed as the output. This method call returned the value true. We assign the value to the variable, and then we print it. After our camping trip, we will want to remove the items from the backpack. And how can we do that? By calling the remove item method. What do we want to remove first? Our famous water bottle. So after we remove that water bottle, we are going to check if it was removed. Right here, we can see that it was removed successfully. Previously, we had a water bottle and a sleeping bag, and now we have a sleeping bag in our backpack. So that is the only thing left to remove. Sleeping bag right here, and then we are back to an empty backpack like we had when we started. We removed the two items. Let's also see what happens if we try to remove an item that is not in the backpack. For example, candy. And we print it. Let's go to our method definition to see what could happen right here. We say if the item is in the backpack, if it is in the list of items, we remove it. In this case, if it's not in the backpack, we return the value 0. We could potentially also display a message saying this item is not in the backpack. Okay, and return the value 0 in case we need to use that value for some operation. If we save the file and we run the code, we see that the item is not in the backpack, and we still have an empty backpack after we call this method. Great, I hope you liked this example and that you found it helpful to practice calling methods of your class. You can see how your classes are starting to grow in complexity and functionality, and they are becoming more powerful. Great work so far during the course. If you need to, you can also assign default arguments to the parameters of a method. These act like default values that we assign in case we omit the arguments. Let's see them in detail. You just need to add an equal sign and then the value that you want to assign by default to the corresponding parameter. Right here, we would write the name of the parameter, and right here, the value. Like this. The parameter or parameters with default arguments have to be at the end of the list. They must always be at the end of the list, okay? Otherwise, you will get an error. Let's see what the Python style guide recommends for writing or defining default arguments for our parameters. We can find more information about how we should assign default values to the arguments by going to PEP8, the style guide for Python code. Right here in the table of contents, we just go right here to white space in expressions and statements, and we click on other recommendations. If we scroll down, we will quickly find this part of the documentation where it says, don't use spaces around the equal sign when used to indicate a keyword argument or when used to indicate a default value for an unannotated function parameter. That is exactly what we have right here. Annotations in Python are a completely different topic, but what we are using right here is an unannotated function parameter. When we indicate a default value for that type of parameter, we shouldn't add spaces around the equal sign. Now think about a player class with 4 methods: move up, move down, move left, and move right. Each one of those methods should have 5 as the default value for the increment in their x or y coordinate, increment or decrement depending on where you are moving, okay? Try to implement this in your code, in your class. Pause the video for a moment, try to write the code, and then come back. Let's write our player class. We're going to do this real quick, the init method, and we're going to define the x and the y instance attributes for each player. Let's say that we are representing a player for a video game where we have a coordinate system. Let's start defining our methods: move up, move down, move left, and move right. We're going to start with move up. By default, instance attributes should always have self as the first parameter. But now, for a second parameter, we will have to specify how much we want to change the position of the player. If we assume that moving up means incrementing the value of y, then we would just increment that value by the value of change. Then we pass this argument. But let's say that we want to assign a default value for change. In that case, we would just write right here an equal sign and the default value. This way, if the user calls the method moveUp without passing this argument explicitly, then this value will be assigned by default. Great, let's see another example with the next method, moveDown. We will do exactly the same. We want to change this by a value of 5. So we want to move up or down by the same amount by default. Instead of adding the change, now we are subtracting it. Now let's go to the moveRight method. This is similar to moveUp and moveDown, but instead of updating the y coordinate, we will update the x coordinate. And now we will assign the value 2 as the default change horizontally. moveRight will be incrementing the value of x, and moveLeft will be another method that will change the value of the x coordinate. It will reduce it by the default value 2 if we don't specify a value for the change. Of course, we are always assuming that change will be a positive value. Great, so now we have our player class with these 4 methods that will let us move our characters in the x and y plane. So let's create our player instance. My player, player. And what do we have to specify for the player? Well, the initial x and y coordinates. Let's say that initially we want the player to be at 5, 10 at this location. Let's call the method moveUp. We want the player to move up initially. And you can see that since the only parameter that we've defined right here besides self has a default value, we can call the method without passing any arguments. We don't see any errors right here. Let's call the method, and after we call the method, let's print the value of y. Let's print it before and after we call the method so we can see the update. Right here we see the initial value 10, which we assigned right here, and then we see 15 because we moved up by the default change, which we defined to be the value 5. Previously we had 10 and we incremented that value to 15. Great, so let's see what happens if instead of using the default value, now we pass a specific value for the change. Let's say 8. You can see that now the value went from 10 to 18. So the change was 8 instead of 5. This argument that we specified replaced the default value that we assigned. When you do this, you are giving the user the opportunity to customize this value. But if the user chooses to omit it, then the default value is assigned to that parameter. Now let's see what happens if we write moveDown. Right here, if we call moveDown and instead of passing a custom argument, we just use empty parentheses. Now the value of y went from 10 to 5 because we decremented the value of y by 5, the default value. Let's say that we pass a custom value like, for example, 3. Now we go from 10 to 7. We are decrementing the value of y by 3, which is exactly what we expect from this method. And let's see what happens if we try to move horizontally. moveRight. Now we will be updating the x coordinates, so let's update these print statements right here. Initially, our x coordinate is 5. That is correct. And when we move to the right using the default value, which we set to be 2 right here, now the value of x is 7. We go from 5 to 7, which is correct. Let's customize this value to be 1 instead of 2. Now we go from 5 to 6. Now you try to call moveLeft, use the default argument, and pass a custom argument. Pause the video for a moment and try to do this. Call moveLeft. Welcome back. Now let's see what moveLeft does to the x coordinate. We had 5, and now we are decrementing it by 2, so we reach the value 3. And if we customize this value, for example, let's say that we want to move 10 units to the left, we are decrementing the value from 5 to -5. Awesome! Now you know how to assign default arguments for the parameters of your methods. Great work so far. When you're ready, go to the next video to continue practicing your skills. Welcome to this practical coding session, where we will continue working with our backpack class. Now we will add another method that will show all the items or print all the items that are currently stored or contained in the backpack. This method will have a default argument. The default argument will determine if the list is printed alphabetically or not, if the items are sorted in alphabetical order or not. So let's implement this right here. We go to the bottom of the class after the last method and we add the method show items. We could also say print items or display items. You can choose the name that you like the most. Show items. This argument will determine if we print the items sorted in alphabetical order. By default, this will be false. So we will present them in the order that they were added to the list. But if we choose to make this true, we have to pass an argument, the value for it, and that will present the items in alphabetical order. So we say, if sorted list is true, we don't have to compare this to the truth value because this is already true or false. Then what are we going to do? Well, we are going to print a sorted version of the list of items. And this is how we can do that. With the sorted function, we get a copy of this list sorted in alphabetical order since we are storing strings. We're getting a copy. We're not modifying the list at all. This function is different from the sort method, which does mutate the list. So you might want to read more about the differences between the function and the method. Else, if the user is not asking us to sort the list, we use the default argument, which is false. And we just print the list of items like they are stored in the backpack in the order that they were added. Let's see how this works. We have our method defined, so now we can create our instance of backpack. And we're going to add some items to the backpack. We're going to add a water bottle, we are going to add a sleeping bag, and we are going to add some candy. Now the backpack has these items. Let's say that we want to show the items that are in the backpack, like we have x-rays or something. We can see everything that is in the backpack. First of all, we are going to see what happens if we don't ask the method to print the items sorted alphabetically. We write the instance and then we call the method show items. But we are not going to customize the argument. We are going to use the default argument that we assigned right here, which is false. This will print the items in the order that they were added to the backpack. And now we want to print the items sorted, like this. And for that, we have to pass an argument true, right here. To replace the value false that would have been assigned by default, we pass the value true. Great, so let's save the file and run the code. And we see this right here as the output. When the list is not sorted, we see this output: water bottle, sleeping bag, and candy, the order in which we added the items to the backpack. But if we do ask the method to sort the items, then they will be sorted in alphabetical order: candy, sleeping bag, and water bottle. So this is an example of how you can assign default arguments for the parameters of your method and how they can impact the output and the behavior of the methods. Another very helpful tool that we can use in Python is calling methods from other methods. This way, you can reuse the functionality that you already implemented in the class. If you already wrote some code to do something in your class, then you can reuse that code by calling the method in your class, in another method. If you're calling, for example, method B from method A, so you're making the call right here, and you're calling this method, this would be the basic syntax. In the body of method A, this box, this blue box, represents the body of method A, you would write self dot method B, the name of the method that you want to call. And then within parentheses, you pass the necessary arguments. It's just like calling a method, like we have been doing so far. But now we are replacing the object or instance that used to be a variable with the word self, because now we are working inside the class, and we need that class to work for every single instance. So instead of just specifying a specific instance, we use self to refer to them in a general way. In this practical coding session, we will see an example with our backpack class of how you can call a method from another method. For example, let's say that we want to implement some functionality in our class that will let us add multiple items at once. Instead of just calling the addItem method and passing one item, we want to define a method that will let us add multiple items at once by just passing a list of items. We can do this by defining a new method. Let's say, for example, add multiple items. You can customize the name of this method, add multiple items. And we will assign the name items to this parameter in plural because this will be a list of items. What do we want to do in this method? For each item in the list of items, we want to add that item to the backpack. So how can we do that? Well, we have a method for that precisely. We are taking a list of items and we are iterating over all the elements in that list. And then for each one of those items, we can add the item like we do right here. We are going to reuse the code that we already wrote by using self.addItem. And what item are we going to add? The item of the current iteration. This is really nice, right? For every item in the list of items, we are going to add that item. Self is the instance of backpack, okay? Self is the instance of backpack, and this is a list of items. We can call the addItem method right here and reuse its code. We use what we wrote within the class already in another method to add an item. Let's test this new method right here by creating a backpack instance. Backpack, and what are we going to do? We're going to call the method add multiple items and we are going to pass a list. Let's add a water bottle and candy. We're going to add these two items. And remember that right here we are passing a list as an argument because we want to add multiple items to our backpack. To check if the items were successfully added to the backpack, we are going to print the list of items before we call this method, and then we're going to check this value again after we call this method. So let's save the file and run the code. Right here we have to add another line, and you can see the output. We see an empty list right here because the list of items is initially empty. And then after calling the method add multiple items, we see the list with the two items that were added by the method. This argument was a list. All the items of the list were added individually by calling the addItem method. The code ran, and within the code, we were calling another method of the class, addItem. So we reuse this code and we avoid writing it again right here. This is really essential to make your classes more concise and to avoid code repetition, which is always recommended in software development. Great, so now you know how to call a method from another method of the class. You just write self dot the name of the method and you pass the necessary arguments, omitting the value of self. Whenever you call a method, even within the class, you have to omit self in the list of arguments. Right here we have self, but we just pass the item, and that is very important.